Welcome back to another explainer. Look, if you're a builder or a focused learner trying to understand the absolute cutting edge of AI data retrieval, you are in exactly the right place. Today we're unpacking a super practical tutorial from MarkTech Post. We're going to take their comprehensive guide and totally transform it into an easy-to-grasp builder's blueprint. Together, we are going to explore how to build a RAG anything pipeline step by step. So let's just jump right in.
I want to kick things off with a simple, but honestly incredibly frustrating question. How on earth do you search through charts, tables, and mathematical equations? Seriously, think about the limitations of standard text retrieval. It works great, if you're just feeding it a plain text file. But the moment you are faced with messy, real-world data, like a typical corporate PDF where simply trying to copy one paragraph somehow breaks the space-time continuum, standard systems just hit a brick wall. They literally can't see the data.
The leap we're taking today is massive. Standard text-only RAG is completely blind to visual context, and it just ignores complex formatting altogether. But the RAG anything framework actually processes text, tables, LaTeX equations, and images. It unlocks full cross-modal reasoning. We're talking about establishing a system that doesn't just read words, but actually comprehends the entire structure of your documents.
Okay, here's our blueprint for today. We'll cover the multimodal RAG era, setting up the environment, prepping multimodal content, wiring the AI brain, running hybrid retrieval, and finally, multimodal queries in action.
Starting with Section 1, the multimodal RAG era.
The crucial point to understand here is that we are moving way beyond simple blocks of text. Standard RAG just isn't enough anymore because the real world is, well, it's messy. It's filled with complex, multi-layered information. In this explainer, we're laying the foundation for a machine that actually comprehends all these disparate data types at the exact same time. This is what allows you to ask questions that require synthesizing an image with a table and a paragraph of text all in one go.
All right, Section 2, setting up the environment.
Before we get to the really cool stuff, we've got to handle the plumbing, right? Think of it like prepping your workspace in Google Colab. First up, we install our dependencies, which importantly includes repairing the pillow library so our image processing actually works. Second, we configure our working directories, output folders, and logs, so RAG anything knows exactly where to look. Step 3 is vital for keeping our runtime practical and safe. We securely capture the OpenAI API keys using hidden inputs. And finally, we define the specific models and embedding dimensions that will power our logic. It's all about building a clean, secure foundation.
Moving right along to Section 3, prepping multimodal content.
Now, you might be wondering, why go through the hassle of generating a synthetic multimodal report instead of just uploading some random PDF? Well, the answer is control. By building a custom synthetic report from scratch, we create a perfectly controlled testing environment. It lets us clearly and precisely observe exactly how the system handles different content types, without all the noise of unpredictable formatting errors getting in the way.
So what's actually in the synthetic report? We're exporting a single PDF that is packed with text passages, structured markdown tables, complex LaTeX equations, and generated figures like charts. We are purposely throwing a really diverse mix of elements at the retrieval system just to see if it can truly handle, anything.
This is where the magic actually happens. Before the AI even reads the data, we convert our synthetic report into RAG's anything-specific content list format. Think of this format like a universal translator. It takes our messy PDF and represents absolutely every element, tables, equations, images, as completely separate structured blocks, complete with their captions, page indexes, and file paths. By saving all of this as a clean JSON structure, we make it incredibly easy for the system to digest and accurately index the information.
Okay, Section 4, wiring the AI brain.
Now it's time to connect the cognitive functions of our machine. We wire up the brain by hooking in clean OpenAI-powered functions. We explicitly define functions for text generation, vision generation, so the AI can actually see our charts and embedding creation. Once those are defined, Step 4 is absolutely crucial. We wrap the embedding function with LightRAG's embedding func. That specific wrapper is what allows RAG anything to use these capabilities smoothly during its indexing and retrieval phases. We're essentially giving our pipeline its eyes and its memory.
Section 5, running hybrid retrieval. To actually get things moving, we turn the machine on by initiating RAG anything, using those directory and parser settings we set up earlier. Next, we have to make sure we explicitly enable the multimodal processing options, otherwise the system won't know to look for anything beyond just text. And finally, step 3, we insert that perfectly prepped JSON content list right into the system. RAG Anything takes over from there, processes those disparate blocks, and indexes them into one unified knowledge base.
Understanding these retrieval modes is honestly the secret to mastering this whole pipeline. The tutorial tests 4 specific modes. Naive is just your standard similarity search, which is great for direct text matches. Local focuses on specific entities and gives you really detailed context around a narrow topic. Global kind of steps back and uses broad community summaries for high-level overviews. But the real star of the show here is hybrid. It combines local and global retrieval, making it perfect for comprehensive answers that require both broad context and deep, specific reasoning across totally different types of data.
And finally, Section 6, Multimodal Queries in Action.
We're not just going to lob softball questions at this thing. We run explicit queries that force the system to sweat a little bit. We test its ability to reason over structured table values to compare performance metrics. We ask it questions that literally require it to understand the actual scoring logic locked inside a locked-tech mathematical equation. But most impressively, we test cross-modal reasoning. That means forcing the AI to simultaneously evaluate a data table, an image, and a text paragraph just to formulate a single cohesive answer.
And boom, here is the payoff. We have successfully assembled a working pipeline where completely disparate data types aren't just stuck in their own little silos anymore. Instead, they all contribute to a shared, intelligent retrieval system. Whether the answer is hidden in a chart, an equation, or a paragraph, the system finds it and synthesizes it. And it's definitely worth noting that while we used a highly controlled JSON list today, the pipeline does retain an optional full document parser path for when you want to experiment with deeper, raw PDF ingestion later on.
I really want to leave you with this core takeaway from the tutorial. Text passages, markdown tables, LaTeX equations, and generated figures can be represented as separate content blocks while still contributing to a shared retrieval system. Seriously, the era of text-only search is officially behind us. I highly encourage you to open up that Colab notebook from the MarkTech Post tutorial and actually try building this yourself. Because think about it, if AI can now simultaneously reason across your charts, your math, and your text, what previously unsearchable dark data in your own organization is suddenly a complete goldmine. Keep learning, keep building, and I'll catch you in the next explainer.